Alright guys, back on 2.2, we're on page 31. We're going to finish up 2.2 notes. On the top up here we just did this ratio, direct variation. 21 divided by 3 is negative 7, negative 14 divided by 2 is negative 7, and negative 7 divided by 1 is negative 1. Underline the correct word to complete each sentence. Since the ratio y over x is the same for all of the input-output pairs, the function is not a, just is a direct variation. So we're not going to read that part. Is a direct variation. And you know the consistency here, this is supposed to be negative 7 here, by the way, up here. So down here it's supposed to be is and is. Down here, if possible, identify the constant variation and write the function rule. So we divided them all, we got negative 7 for all the k's. So to write the function rule, and remember the function rule is y equals kx, where k is the constant. And you put in the constant, when you divide them all, you get negative 7. So we're putting in negative 7 for that k right there. Number 2, identifying a direct variation from equations. From the function 5x plus 3y equals 0, determine whether y varies directly with x. If so, what is the constant of variation? So you have, and I'm not going to do it their way, I'm going to do it a little different way. So we have 5x plus 3y equals 0. Get all the x's in this side first by subtracting 5x. You have 3y equals minus 5x. Divided by 3, y equals negative 5/3 x. So we solve for y. Now you circle the constant. The constant is the k right there. So it's negative 5/3. It's the only one that makes sense. Number 3. Let me try to zoom this out a little bit here. There we go. Using a proportion to solve a direct variation. So suppose y varies directly with x and y equals 15 and x equals 3. What is y when x is 12? And these are the tricky ones. We got to use our formulas. First we know y equals kx. We also know x equals y over k, depending upon what you need to solve for first. So they give us y and x. So y and x is here. And you could also use k equals y over x. So we know y and x, we need to find k. So we put 15 over 3 in this formula right here. So let's do that. 15 over 3, look right there, they did it for you. And 15 over 3 is 5. So we don't need to do all of their cross multiplying if we don't want to. We can just do 15 divided by 3. K equals 15 divided by 3, which is k equals 5. And simplify the proportion for exercise 14. We already did that over here. So k is 5 is the most important part. Problem 4. Use a proportion to solve a problem. So 200 milligrams to 50 milligrams is the same as the ratio of C calories to 70 grams. So 200 over 50 equals C over 70. Solve the proportion for C. You're going to solve for C. So they want you to do this old school cross multiplying. So it should be 50 C equals 200 times 70, which 7 times 2 is 14. You had 1, 2, 3 zeros there. You get 14,000. Solve for C by dividing by 50 on each side. C is all alone. Half of 1,400 divided by 5 should be 280. Again, I do it a little differently than they do. So there are about 280 calories and 70 grams of cheese. There's your answer right there. 280 calories of cheese. 20 is one that you'll see on your homework. Complete the table. What is the graph of the direct variation equation y equals negative 2/3 x? And you can put this directly into Desmos. And Desmos will graph it for you. There's a couple other ways you can do this. You can solve it by putting the numbers in all these, this graph here. So x is negative 3. So y equals negative 2/3 x. First thing we're going to do is we're going to plug in negative 3 for that x. Y equals negative 2/3 times negative 3. So negative 3 times negative 2 is 6. 6 divided by 3 is 2. So y equals 2. And we got that over there. You can see it. Then you put 0 in. 0 multiplied by x is going to be 0. And remember, for it to be a direct variation, it has to be 0, 0. It has to go through here. This is your origin, and it has to go through the origin to be a direct variation. If not, it's just a linear graph. Then next time we're going to put in 3, and the opposite of negative 3 is 3, and so if this is 2, this has to be negative 2. So there's our graph. We graphed those 3 points, and we got that graph. And again, you can also use Desmos to solve that equation. Now we have the lesson check on 2.2. And this is what we were just talking about, direct variation linear. Remember, for it to be direct variation, it has to go through here. So this is a direct variation, this is a direct variation, and this one does not go through 0, 0, so it has to be linear because there is no line does not pass through the origin. The origin is 0, 0. Number 23, write D if the equation describes a direct variation, write L if the equation describes a linear function as not a direct variation. So again, it has to be just like our function here, y equals kx. So the first one looks like that, so we would say direct variation. The second one looks like that, because remember the k could be a 1. And the third one has this other thing, it looks like a +2. Well, this doesn't look like the same formula. So we're saying this is linear, because this is the y-intercept. The y-intercept is going to be not through the origin, it's going to be 2 dashes up. Number 24, circle the true statement. A direct variation is always a linear function. That is true. But a linear function is not always a direct variation. Here's our formula. Y equals kx. It's asking for the formula. And then you're putting 0 in for k. For x, you're going to get 0. So that'll be 0, 0. Then they're asking here, why does a graph of a direct variation function always pass through the origin? For example, if you put in 0 for x, k will be 0. Put in k 0 for k, x will be 0, and that'll make y equal 0. So it's always going to be 0, 0 using this equation. So, any questions, come see Mr. Weckeser. You can start 2-2 homework, and have a great evening.